Welcome to a video tutorial by ET System Electronic GmbH, your specialists for AC and DC power sources, electronic loads, and DC sources with power regeneration. On the left side of the device is the display. To its right are 5 jog dials with which the respective values of the device, such as voltage, current, frequency, etc., can be set. In addition to the controls, there is a keypad with 16 keys, which are used to make further settings. On the right side of the front panel is an output socket, and below it BNC sockets for connecting AC and DC voltage and the earth connection. When the device is switched on the display, you can set the contrast of the display with the jog dial in this time. The contrast setting remains even after the device is switched off. The source designation is displayed in the top left of the screen. In this case, it is an EAC 1000. Below, you can see the current device output values for voltage, current, power, and frequency. As the device is in standby mode, all the values except frequency are currently 0. In the left corner of the screen, you can see that the AC waveform is switched to sine. It also shows that the device is in standby mode, and thus the output is currently not released. LOC on the display also informs us that the device is operating locally and is not being controlled remotely via an interface. After pressing the preset switch, the output voltage can be set using the AC voltage jog dial, in this example 230 volts. The third controller from the top, current, is used to preset the maximum current. Here it is 5 amps. Press the preset button now to get back to the normal display. The standby button releases the output. Now the values which the device supplies at the output are displayed. You can switch between the various displays by pressing the display button. This diagram shows all of the values the device can display. The AC power source output is blocked by pressing the standby button. For better illustration, an oscilloscope has now been connected to the source. When the output is released, a uniform sine curve can be seen. Our source display now shows that the device is set to 50 Hz. You can also see that on the active key on the keypad. In this row of keys, the fixed frequencies 60 and 400 Hz can be pre-selected, or the frequency range can be set to variable. In the variable mode, the frequency can be smoothly adjusted with the lower jog dial. In the second row of the keypad, you have the option to adjust the waveform of the output signal. Sine stands for sine curve, rect for square wave, and triangle for the triangle wave. You put the device back to sine and block the output with the standby button. If you go back to the preset mode, you can adjust the start phase position from +359.9 to -359.9 with the phase controller, the second one from the bottom. In our example, the setting is changed to 90 degrees plus. If the output is now released again, you can see that the signal now starts and ends at 90 degrees plus. Conversely, the same is true for the negative range. You now switch the source back to the basic settings. By pressing the display button, you jump to the next presentation. Here, the DC component will be displayed in the second row. If you hold the DC button and release the output, you can lay a DC component on the sine by turning the DC voltage controller. This is true in both the positive and negative areas. On the display, you can now read off the effective AC voltage, the DC voltage component, the peak voltage, and the crest factor. By repeatedly pressing the display button, you can now switch through the different displays. Depending on the display, Different parameters for current, power, and other measured values are displayed. Pressing a button disables the DC component again, and the standby releases the output again. In addition to the preset voltage, you now see the actual current flowing through the specimen or consumer. Now turn the current controller to the maximum current under the actual value, and you see that the device is switched to the I-limit mode and the voltage comes down accordingly to remain constant at the value set. If you increase the current appropriately, you can disable the current limit again and the unit returns to normal voltage mode.